On the first experiment, we calculated the mass of both the container we use and the water source, along with the rate at which it is filled to draw out the water flow. We use the formula in which Q is equal to the volume of the tap divided by the speed at which it fills, obtaining 64.22 G-A's. Now we multiply P by the radius of the container squared to obtain the volume, and that's all.
In the second experiment, we did the following. We filled a container with water, and we placed in a ball of clay and a ball of clay to see how the volume of both clays interact with the volume of the water. In fact, we saw how much the water increased once we place in these two objects and once we take out these objects. Everything to observe the buoyancy force. We in fact saw that the ball didn't float, it sank, and the boat, obviously, it floated. And that's all we saw. It was an interesting experiment, I have to say.
For the experiment number 3, we need to calculate the force to lift a 500 grams object with a 20 millimeters syringe. First of all, we need to use the formula that is pressure equals to force divided into area. And well, the force we need to convert into kilograms. So the 500 grams is equal to 0.5 kilograms. And if we want the force in newtons, we need to multiply by the gravity, and it gave us the result of 4.905 newtons. Then we need to calculate the areas of the syringes. So we have to multiply P by radius squared. That for the 20 milliliters syringe is 3.14 multiplied by 10 to minus 4 potential. ¿Cómo se potencia?
Potential.
Bueno, Valencia, aquí le cortas. Potential meters square, and for the area of the 3 milliliters syringe is 5.03 multiplied by 10 to minus 5 meters square. And then we need to use the formula that is pressure equals to force 1 divided into area 1 equals to to force 2 divided into area 2. Then if we isolate the formula, we have that force 1 is equal to force 2 divided into area 2 multiplied by area 1. And if we substitute that formula, it's 4.9 divided into 3.14 multiplied by 10 to minus 4. And then we need to multiply that for 5.03 by 10 minus 5, and it gave us the result of 0.7849 newtons. And that's all.